Okay, so we might get started and then hopefully we get some additional people to join. My name is Didier and I'm part of the HP developer community. And today for our meetup of October, we have together, we have invited Heidi and Kirk. Actually, we have a little problem with Kirk, but we might get Kirk as we start the session. But we have instead Manuel has joined also from Pepperdata, and together with Heidi, they're going to talk to us about boosting Spark AI workload with Pepperdata. And before we do that, and before I hand over to them, I will just give you a few additional piece of information about upcoming sessions. We, as part of the developer community program, we run two series of talks, one called Dimension Learn, and this is more like a thought leadership type of session with more vendor agnostic and product agnostic. And we have been running this since January 21. We have a page dedicated to the calendar of these events, so you can find the upcoming sessions and the replay links for all our past sessions. We have a session coming up in November. There won't be any session in December, but there is one for November, and it's going to be on low code and no code and notion of citizen developers. So feel free to join. I think in the chat, if you bring up the chat, my colleague Denis and Fred will dump all the links that you need to know to register for this session directly. We also run another more in-depth series of talks, and this one is part of that series. We call them meetups, and these are more open source and more in-depth technology series. And we have a fair amount coming up in November and December. So we have in November a session on Kubeflow, introduction to Kubeflow. And this is going to be done by two person from Aricto. And then in December, we changed the calendar to have two meetups in December instead of a meetup and a Munch and Learn. And we are focusing on the reliable system. So ESRI, in part one, December 7th, we'll run an ESRI overview. So that's site reliability engineering. And then on part two, 1 week later, we'll have a SLO, service level objective math. And these two sessions will be delivered by Leonid from Google Cloud. So feel free to join these two sessions. The registration links are already available for the upcoming Munch and Learn and the three meetups if you are interested to join immediately. In addition to sessions that we run or our technology talk, there's one particular point I'd like to highlight, which is the workshops on demand. And we have a fair amount of content available in that form. These workshops are Jupyter Notebook based. They are available 24/7, so it's a great way to learn new technology. They are free, and it's kind of a nice way to get hands-on experience on certain technology. We have today almost 30 workshops in the catalog, still growing, and half of them is open source. And you can try those, and you'll get access to a platform that we have built a complete framework that automatically provision on demand the workshop when you request it. Then you can work on it for a couple of hours, and then we'll ask you to provide some feedback so we can understand what you like, how was the experience, and then what kind of topics you'd like to see covered in the future. When I talked about open source topics, you can find, for example, training on Kubernetes 101, another one on Docker, on programming languages such as Rust or Python. And or you can find more data scientist focused topics such as machine learning 101 and some other ones as well. So take a look. It's a great way to learn and get a little bit of hands-on as well using Jupyter Notebooks. And it's free, like we like to remind you. This is a community, and this is the developer community. So we need people in the community to make this work and to continue to amplify and contribute. So if you want to continue to join our talk, that's great. You can also invite others to join our talks. And remember, this is open to external audience. So please don't hesitate to invite other people to join. We also run a monthly newsletter, which you can subscribe to. It's a great way to keep up with what we do on a monthly basis. There's always going to be a link to unsubscribe if we if you don't like it, so you can safely subscribe to it. We also have a Twitter account if you're more like a Twitter person, and you can follow us there. We have a dedicated Slack workspace with lots of channels to discuss technology from HPE or from open source technology that we work with. So you can go there, register, and then ask, start opening conversation there or escalating issues that you have on working with some of our products. We have a big blog section on our website. It's actually half of the traffic of the website. So you can contribute to that. We are using a technology that is based on GitHub and Markdown. So you can fork the repo and contribute to blog. We accept blogs on almost any developer-centric technology or data scientist-centric technology. And finally, you can, if you're an SME, you already developed a blog, you might want to talk to us and maybe do a meetup with us, so or work on a workshop on demand as well. So this is all possible. Remember, this is a community and we need the people to contribute, so it works. You can scan that code to get all those links, but I think Denis or Fred have pasted all the links as I was speaking. Developerhpcom is where everything starts. This team maintains this website. We try to update it on a multiple time per day, so it's fresh and active. And again, you can scan that code to see all the links and find the different ways to join the community. With that, I'd like to get started with the real content and hand it over to Heidi for the rest of the session. Thank you.
Great. Thank you so much, Didier. That was great. I'm going to go ahead and share my screen now.
Yes, please do.
And okay, great. Yeah, thank you all so much for joining us today. Today, we'd like to talk to you about ways that you can boost your Spark workloads with Pepperdata running on HPE Ezmeral Runtime Enterprise. So the things that I'd like to cover today is starting with an overview of Apache Spark. That might be kind of a bit of a basic introduction for a lot of the folks on this call, but it's sort of helpful to just have a common foundation for us to speak from. And then I'm going to talk through some of the typical challenges that Spark developers face, and then some of the solutions that Pepperdata can provide and the ideal architecture for those solutions. We'll talk about some of the things that we do to help accelerate and streamline the deployment of Spark workloads. So just as a way of background, what is Apache Spark? And I know a lot of people are familiar with this, but Spark offers a lot of advantages over other development platforms. For one thing, Hadoop jobs in particular can run hundreds of times faster in memory, many times faster on disk due to efficiency and the pipeline distributed architecture. Of course, it's easy to use. It supports jobs written in all those different languages. It's very generalizable. It powers libraries, including SQL, data frames, graphics, Spark streaming. These can be easily combined within Spark. So it has a lot of great properties for working with different sorts of libraries. And along with that, it's flexibility. It runs on Hadoop and Yarn. All these different Mesos, Kubernetes. It can run standalone or in the cloud. There's a lot of different data sources that it can work with, like Cassandra, HBase, Hive, and so forth. And but that is to say, Spark is, despite all of its flexibility and power, it does have challenges. And some of the challenges that we see that our customers are coming into are things like, on the development side, how to efficiently source the data, how to perform extract, transform, and load operations, how to validate data sets at a very large scale on a multi-tenant system, and how to do all of that while keeping costs under control. On the IT side, some of the things that we're concerned about are how to remain within budget, provide the best quality of service to everyone, really get a grasp on the total utilization across all of your clusters, and achieve the highest possible efficiency that you can. So those are some of the things that we hear from our Spark, the people that we work with in our community. One of the things that we discovered, we did a report a few years ago. We took about 40 different Spark clusters and we sorted them in terms of how utilized they were, in terms of their memory utilization over a 7-day period. We just sorted them from lowest to highest. And as it turns out, while some of the clusters were quite well utilized in the 70s and 80%, Most of them were not. And in fact, the average percentage utilization was well under 50%. So what does that mean? That means that there's a lot of opportunity for unused resources within Spark. So there are many things that we can do here to try to take advantage of that. We also discovered in that same study that we conducted that Spark jobs tend to fail more often than others. So on a typical rate, maybe 4.5% compared to less than 1% for other applications. And what are some of the reasons for this? Well, some of the things that we've seen with all of the Spark jobs running that we observe are memory issues. So oftentimes people will not exactly know how much to allocate and they over allocate. That's sort of a natural tendency. I better give this job more than I think it needs to make sure that it runs. But that leads to the kind of waste that we saw in the previous slide. And as a result, there can be out of memory issues. We also see a lot of issues related to data skew. So in Spark, you have your executors, you have your drivers. If the data isn't provisioned correctly across them, you can end up with some executors being super busy, some being idle, and that's what we call data skew. And finally, there can be some basic configuration issues as well, just in terms of the configurations that were set up at the beginning of the job. So you can look at a lot of different tools to help you address these issues and resolve these issues. And one in particular is the Spark UI that ships with Spark, comes out of the box, has a ton of information in it. You can use it while the application is running. But the flip side of it, of course, is that it has so much information, it may be too much information. It can require a lot of clicking around to get to the information you need. It specifically is good about drilling into one application at a time, but it can also therefore not present you the information you need to look at all the applications on your cluster and really understand how they are playing well or not well together on a multi-tenant system. And then also in terms of applications with many complex stages, this Spark UI may or may not be able to scale as well to handle those kinds of complicated applications. Another tool that you can use that we want to talk about today, of course, is Pepperdata, which provides a lot of information that you might see in the Spark UI, but addresses a lot of those issues as well. Here you can see a sample application running on HP Esmeralda, or sample cluster, I should say, with a number of different applications sorted by which ones are requesting the most CPU, which ones are requesting the most memory. You can see the status of those jobs at a glance, which ones are running, which ones have succeeded. This is a fairly small cluster. It only has 10 applications or 12 applications in this particular run or time frame, but you can see from here how easy it is to just get an overview of all the applications on your cluster. Once you find an application you want to look into, this is an example of the dashboard that you can see where you can drill into a lot of different details about that application. So for example, at the top here, we have the details of the app, when it started, when it ran. We give an allocation charge to it that's based on what you tell us that you pay for CPU and memory. You can see what its usage was. You can see its cluster share in terms of how much it takes up relative to all the other applications running on this cluster. Down here below, we have some interesting, unique things that are specific to Pepperdata. For example, these recommendations. This will tell you that this particular job has a configuration issue with the Spark serializer config. And right now that hasn't been set, but we are proposing a value you can set it to. So this is an example of the type of recommendation I mentioned earlier that could require or a type of issue that could require an improvement. You can make an improvement to it by simply changing this configuration value according to this recommendation. And we offer other recommendations as well, and I'm going to get into those in a little bit. You can also see alarms that this app you may have set for this app in terms of notifying you in terms of changes to its behavior. There's a whole detailed screen where you can drill into its behavior as well under the Spark tab here. And you can get at a glance its resource usage, historical information about runs of this app, previous runs of this app, and more information about the configs. And actually, Kirk is going to take you through this in the demo later. Just drilling down into a little bit more detail, here you can see for your cluster all your namespaces. You can see all the details of them, their usability, usage, how many requests they made, memory usage, and so forth. And where the fields are colored in a different color, for example, here, this orangey or yellow color, this is something that you might want to pay attention to in terms of being outside of the norm or outside of the behavior of the other applications running on this cluster. So continuing onward, I mentioned some of those recommendations. Those recommendations that we make line up really nicely with the issues that we tend to see. So I mentioned memory allocation. Here's an example of a Spark job where the Spark executor memory was sent to 10 gigs, but we think based on its usage, you really only need 3. So there's a lot of memory usage that you can recover there, 7 gigs, if you change it from 10 to 3. So we make those recommendations for you to help you run those jobs smarter over time. I mentioned data skew being an issue. There's another recommendation here, a critical recommendation letting you know that there was some skew in the executor average shuffle read bytes. So that gives you a little bit more detail here, and it gives you specific instructions about how to speed up your app. Increasing the number of partitions in stage 114 and so forth. And finally, I showed an example of a configuration recommendation, but here's another one there where we would recommend that a certain configuration be enabled.
And Heidi, this is Manuel. Just if I may interject, just to let everyone know on the call that if you click on the Q&A tab, you can ask questions as we go through the presentation, and we'll address them as they come in.
Great. Yeah. So just summarizing what I've shown so far, the waste that is kind of inherent in Spark can lead to a lot of waste on your cluster, which can translate directly to cost. Some of the most common issues I mentioned, the memory, the skew, the configuration issues, and you can use tools like the Spark UI, Pepperdata. There are others as well, but a various number of tools can help you identify these major issues and address them. And that's great on an individual level, but there are certain situations that we run into with most of our customers where they're operating at massive scale. There's IT teams that are struggling to keep up with the demands of hundreds or even thousands of users and applications working together, competing for resources, trying to get done what they need to get done. So that is the solution where Pepperdata also positions itself. And I want to just kind of give a little bit of an overview of why Pepperdata is a great partner with HPE Ezmeral Runtime Enterprise. Both solutions offer high performance analytics, and HPE definitely offers high performance analytics. Pepperdata offers this cost reduction by recovering all of that waste that I demonstrated earlier, as well as the observability in terms of being able to drill down into your Spark apps. And both companies' solutions are being implemented and trusted by large enterprises among the Fortune 500. So we've run Pepperdata on HPE Ezmeral Runtime, and on HPE Ezmeral is a solution that, as it says here, runs on premises on the cloud. It's an integrated platform for AI, big data analytics, data science, has a self-service portal, great performance. And then Pepperdata on top of that adds the optimization capabilities that I'm going to demonstrate, the observability that I alluded to earlier with the dashboards, the alerts that I mentioned, chargebacks, and then the recommendations as well. So working together, both solutions can really support customers who are looking to run large-scale Spark clusters. So just getting into Pepperdata a little bit more, I use that word optimization. What does optimization actually mean? Well, we are addressing Spark clusters and trying to improve them in 3 different ways. So the first way is called capacity optimization or optimal capacity utilization. It's like a little bit of a Tetris game here where we try to fit in jobs into those unused or allocated but unused resources. That's often the case, that systems will allocate resources and then not use them. So we fit in those jobs into those unused resources. We also have a capability that provides cloud instance selection. So in the cloud, we'll recommend for you your optimal cloud instance. So you may not be aware of the properties of all the 500 cloud instance types, for example, on AWS or any of the other clouds. They all offer hundreds of different instance types. And it's really impractical for you to go discover which ones might be optimal for your workloads. So we have a tool that uses AI ML and can identify the proper configuration of instances for your unique workloads. And then also with cloud auto-scaling, the cloud native autoscalers do a great job kind of raising the resources available to you as needed, but we find that oftentimes they don't then scale back down as your workload changes. So one of the things that we're working on or that we've developed is a tool that leverages that native cloud auto-scaling and allows it to perform even more effectively, utilizing instances fully before we add more, and also downscaling when needed. This is an example of what our capacity optimization functionality does. Let me just, sometimes we have this as a build, but basically the idea is there are 3 jobs right now, jobs 1, 2, and 3. We have these in our queue, and our cluster resources amount to this empty box here. So if we put jobs 1 and 2 into that available cluster resource, we find that we have a little bit of unused left over, but we don't have enough in that unused space to fit job 3. Well, the beauty of this is that Pepperdata finds the waste, which is the allocated minus the used resources in real time, finds that job 2 really doesn't need quite as much as it thought it needs, same with job 1. So there's a little bit of waste in job 1, a little bit of waste in job 2, combined with the unused resources. If we put those together, we have enough room for job 3 now. So this is a very simple kind of schematic, just giving you a picture of how we're able to basically do more with less. And the way we do this, and there's a little bit of a graphic here showing this PEP agent. We have a tool that we call the PEP agent that we install on your cluster. It's only read-only, and it gathers hundreds of metrics every 5 seconds to really understand what the exact usage of your jobs is, so that we can make the determination of how much is wasted, recover that waste, and then insert an additional job, let's say job 3, into that waste. The way you can visualize this is in the dashboard. So I showed you the dashboard earlier, the Spark UI dashboard, and as well as Pepperdata's version of that dashboard that allows you to drill into the Spark details. Here, we're rolling up all of that information into a picture of what you've actually saved. So this is a cloud cluster where over the last however many days this has been, they've effectively saved $41,000. And that is represented below. You can see in this kind of mountain range, the uplift that Pepperdata provided is this higher level mountain range. It's shown as pink here. That is your gain that you're able to achieve by recovering the unused resources, inserting more jobs into those unused resources. And you can see here, it also translates very directly into core hours saved, memory hours saved, uplift in the containers, uplift in the instance hours, and really coming down to what is your price performance ratio. That's something that Gartner often talks about as your metric in the cloud. What is your price performance ratio? What are you getting for the money that you're investing into your cloud? And if you can get a number like 6 or 4, that's those are really great numbers, because you're seeing a lot of uplift over what you would be able to achieve otherwise. Okay, so one of the topics we also want to cover is what would be an ideal deployment environment for deploying Pepperdata? Where does Pepperdata do best? Well, we tend to work best at large scale on very high volume Spark clusters with a lot of complicated situations, things like analytics, data science workloads, AI/ML workloads, workloads where we're running batch jobs, lots of applications contending for resources, lots of jobs waiting in queue, as I showed in that diagram earlier, jobs with runaway characteristics. The workloads are changing, the data is changing, and we work equally well in on-prem environments as well as public cloud environments. Okay, with that, I've kind of given an overview of what Pepperdata has to offer. And if Kirk is on the line, I would like to hand it over to him to kind of walk you through the actual live dashboard.
Hi, Heidi, this is Manuel. We've been trying to solve this issue, but he's not able to join for whatever reason. I think what you may do is just, why don't you get started if you have access to it, and then we'll continue trying to see if we can get Kirk on the line.
Okay, sounds great. So I'm going to, I'll just give the demo myself. So I'm going to do share screen again. I'm going to switch over to my Chrome browser again. And here we go. So I have this up and running over here. Can everybody see this dashboard? So this is just a sample dashboard that you would see when you log into Pepperdata. It's quite busy, but you can see all the different things that are going on in this cluster. I'm running a whole bunch of queries. I'm running on this cluster. This is a demo cluster. I'm running a whole bunch of TPC DS queries. This is a machine learning set of queries that are Spark jobs, basically, that, that are just a kind of a benchmarking tool that we use. So these are not actual customer jobs, but yours might look very similar to this, where I can drill down. I can see all these different apps that are running in the last hour. I can see their name, their type. These are all Spark jobs, but you might also see MapReduce in here. You might also see TES. We also support a lot of query functionality. So if you're running things like Presto, Trino, those would also be available here. You could see the status of each of these jobs. And as I mentioned earlier with the recommendations, I can even sort them by which ones need the most attention. So these at the top here are the jobs that need critical help, and the other ones down here where it says no issues, that's great. I don't have to deal with those right now. You can see who's running them, what queue they were running in, a bit of information about their duration. You might even just see how long they were running. You could see how much memory they used and so forth. So this is going back to Spark observability. You can drill down into any level of detail. And let me just show you, I alluded earlier to this Spark tab. So, actually this application is still running. Let me go get one that has finished. And I will show you some details about it. And I would like to drill down and give you a good example of a job, and you can drill into the Spark details. So for example, this job, very simple job, one stage, 6 executors. You can see that it really wasn't that complicated, but even in a not very complicated job, there are a lot of things that can be looked at in terms of how the job was running. This is the CPU utilization over time. You can look at the memory metrics in the same way. You can drill down to the executors and really get into a lot of information about what those executors did at each particular stage of the execution. So even for a very simple job that doesn't look that complicated, you can drill down into a lot of information to really understand how those executors performed. This is great for troubleshooting, as you can imagine, if there's any aberrant behavior that needs to be examined, and you can really look at it over time in terms of what this job did. So that's an example of the Spark details. Kind of going back up, I can also look at the history of this app, this job. So this job has run many, many times, and I can compare this current run of it with all of its previous runs. So it's been running, every single day, October 25th, 24th, going back in time, and I can compare how this particular run looks based on how the previous runs look in terms of any kind of configuration changes that were made in this particular run versus previous runs. And you can look at all the different details of the cost and the memory and so forth. One thing I do want to show for you, so this is drilling down into individual jobs. There is another really great piece of functionality here, and let me just back up to it, which allows you to compare 2 jobs side by side. So let me just quickly pull that up. I'm going to grab 2 jobs and I'm going to compare them side by side so that you can really drill into them in detail. So let me take 2 jobs here. I'm going to find just, let's say, 2 that have some recommendations. or actually I'll just take these two because they're completed. I'm just going to grab two random jobs and I do compare applications. And you can see side by side, this one application is on the left, one is on the right, and I can see when they started. I can see the names of those jobs. I can drill down into comparatively which one ran longer. So the one on the right ran for 1 minute and 42 seconds. This one only ran for 22 seconds. So this one's much longer. How many seconds it waited in queue, the cost allocated, the cores wasted, and so forth. And so really visually, I can see, okay, the one on the left was a shorter job, but it was a lot more wasteful. And then down here, I can actually compare the stages one by one. So these were two pretty random jobs. I don't even know if they are similar in any way, but you can see the one on the right had a number of different stages, about a dozen different stages. On the one on the left only had one. And this is, you can imagine, is a really great tool for just comparing, you know, I thought this job would run like that job. Why didn't it? Let me see exactly what happened. So this side-by-side comparison tool is something that a lot of our customers find of value. So this is a lot of detail about all of our Spark applications. If you get the Pepperdata dashboard, you'd be able to drill into all of those in a lot more detail. And I do want to show kind of the other side of things, the capacity optimizer side. So this is an actual example of what I showed earlier. So this is a very small cluster. It's only $762 in savings compared to the demo, the other one I showed in the screens that had like $40,000 of savings. But here you can see, even just for a pretty modest improvement that we're able to make on this pretty simple cluster, you can still recover, a good amount of money for not doing much of anything. Just sit back and the optimizer will then find these memory hours and core hours for you that were not being utilized and be able to take advantage of them. So that's an overview of Pepperdata, and I tried to show both the detailed Spark drill down that allows you to really understand your Spark jobs at a level of troubleshooting detail, and then the other side of what Pepperdata offers, the optimization tools, which IT managers love as a way to extract more resources out of their existing clusters and take advantage of underutilized and unused resources. So that is manifest here in this capacity optimizer screen. That's pretty much what I had to share. I'll go back to our slideshow and just kind of finish up from the demo. If in terms of next steps, we'd be happy to demonstrate a proof of value with anybody who's interested. Typically, our proof of value flow looks like this. We do a quick kickoff call for about 30 minutes. The install of Pepperdata typically takes 30 to 45 minutes, less than an hour. Take you maybe an hour through your unique dashboard. So instead of just looking at sample dashboards like what I showed, we would show you your actual dashboard for your cluster setup, do a final review. And then our goal to you is really to deliver a comprehensive analysis of your cluster health and the ROI that you should expect to achieve by recovering those unused resources. And that's it. So thank you so much for your attention and your time today. And I'm here and happy to take any questions, or you can always email us afterward. Happy to continue the conversation.
We are sorry, we are still struggling to get the problem that we are hitting with Kirk, and we're trying to get him another link for joining the session, but unfortunately we haven't been able to. So great job on the demo, Heidi. Any question for Heidi and Manuel, please? We didn't see much questions on the chat or the Q&A. Maybe you want to get a last chance to ask your questions. Please do now, as something in the chat or in the Q&A. There we go. We have a question, finally. Thank you. Thank you, Prasad. Any integration with Data Fabric? So that's Emerald Data Fabric, I suppose. HP Emerald Data Fabric. Do you know Heidi or Manuel?
I'm so sorry. I was trying to still work with Kirk to try to see to getting on the line. So what was the question, if you don't mind?
The question is if there is any integration work going on with the Emerald Data Fabric, which is another component in the Emerald. But Kawai in the background was already answering the question, and he says there is no work done yet. They tested it only with ESRI at runtime. Okay. Thank you, Kawai. All right. Thank you for.
Hold on 1 second. 1 second. I've got a question here. Is Pepperdata GPU aware
Yes.
if customer is using NVIDIA Spark version?
Yeah, we've actually implemented Pepperdata on GPUs, NVIDIA GPUs. So we have a actually section on our website about GPUs. So that has a little bit more information. Yeah, if you go to pepperdata.com.
Perfect. Thank you.
Great question. Thank you. Stephen, any other questions for ID? We have plenty of time for questions, so please take the opportunity to ask your questions. Okay. Shy audience today. Thank you, ID. Thank you, Manuel. I think we're going to close the call. We'll make that available as a replay. And thank you very much for this presentation. And thank you, everyone, for joining. We'll talk to you next month.
Yeah,
Great.
thank you so much for
much.
the opportunity. And maybe just as a getaway, please do not hesitate to contact anyone here on the email. I wanted to add as well that we are sharing customers. So we have customers that are customers of HPE and Pepperdata. So any questions you may have in the future, please go ahead and just reach out to any of us. Thank you so much.
Thank you.
Thank you, Manuel. Thank you, everyone. Bye-bye.